Good morning, class. Welcome to math class. And I'm going to do this as best I can. Hopefully this all makes sense to you. So turn in your books to lesson number 8, function notation part 1. And we're going to start talking about what does it mean to be a function and how is it different from what you've already learned. And to be honest, there's just some notation that's different. A lot of it is the same as just an equation. So I'll just read this beginning paragraph. It says, in the previous lesson, we discovered some ways in which functions can be represented. A graph, ordered pairs, table of values, mapping, and an arrow diagram. A function was defined in mapping notation as follows. A function from a set D, the domain, to a set R, the range, is a relation in which each element of D is related to exactly one element of R. Now this is important, one element. Okay, if the function f maps an element x in the domain to an element y in the range, we write f, that's for the name of the function, then we go x to y. Now consider the function f if x is going to go into 2x plus 3, defined on the set of real numbers. Under this function, we know that 5 is going to go into the machine and be 2 times 5 plus 3. So 5 is going to become, when it goes into the machine, it's going to come out as a 13. So what we do here is we take this 5 and we do to it what they're going to do to x. So to x, they were saying we're going to times it by 2 and then we're going to add 3. So if I give you a 5 in the same machine, you're going to times it by 2, get your 10, and then add 3 and get 13. We say that under the function f, the image of 5 is 13. So when you put 5 in, what you get out is 13. It's kind of like just making a table of values and saying, when I put a 5 here, I'm going to get a 13. It's just different notation with different language. We also say that the value of the function is 13 when x equals 5. That's from this last sentence. And again, that's what you're used to seeing. You're used to seeing your table of values and making it work. Now we just use different words to describe what we call a function. In most math courses, function notation is used to replace the mapping notation. I'm just going to make that screen bigger for you. Sorry if that was distracting. So in most math courses, I'll just read that again. Function notation is used to replace the mapping notation f, and then we say x going to 2x plus 3. Under a function f, the image of an element x is in the domain is denoted by this. Okay, here's what you're going to normally see. This means it's read f of x. That means the function is f. X is what we're putting in to that function. In the example above, the function f can be defined by the formula, and here's what you're going to see. F of x is equal to 2x plus 3. So as I said yesterday, your f machine is going to have an x in it, and we're going to times it by 2, and then we're going to add 3. The notation is called function notation. Okay, so if you wanted to plug in the 5 like we did before, you would write f of 5 and indicate that what you get out is a 13. So here's a few different things you can kind of check. Mapping notation, this is what it would look like. Your function notation, here's what that looks like with the f in it. And then your equations is like this. So this is what you're used to seeing. You've seen that a lot in the past with a table of values especially, right? Where we plugged in the 5 and got a 13. So notice where the 5 goes in this case. It goes in that little spot there, and then you get out your 13. Okay, so we're going to read it f of x. What is super important down here in this little note guy, what is super important is that f bracket with an x or a parenthesis inside does not mean f times x. It means a function f, it's going to have some rules to it. It's going to be a machine that does something, and you're going to put x into the machine. The values of the independent variable over here on this side represent the inputs of the function known as the horizontal axis. Again, we have this idea that we have an independent input horizontal axis, which of course are the x values. Okay, the name of the function is f. That's just the name of it. And that's going to get out the dependent, the output vertical axis, also known as what we used to call the y values. Okay, So here it says that the f machine, f of x, is equal to x squared plus 5. That means whatever the input is, whatever our x is, we're going to square it and add 5 to it. Then it also tells us that the g machine, is 4, take away whatever the input is. So let's go evaluate some. This tells us which machine to use. We're going to use the f machine, and we're going to take our input, which is a 3, and we're going to square it and add 5, which gives us 9 plus 5, which is 14. So as we simply took our input, which was a 3, and everywhere we saw an x, we put a 3 instead. Letter B, g sub 1, or g of 1. So g of 1 means I put my 1 everywhere there's an x. So I'm going to go 4 minus 1. This x was replaced by a 1. So this x is replaced by 1. And my answer is 3. Now, when it's a negative, we have to be a bit careful. Letter C says take the f machine. So plug the negative 2 into the f machine, which means I have to take the negative 2, square the whole thing. Notice my parentheses, and add 5. So I get 4 plus 5, which is 9. Okay? Letter D, g of negative 2. That means take your g machine, which is 4, minus your input, which in my case is a negative 2. So 4 plus 2 becomes a 6. Now f of 0 minus g of 0, I actually have to do both. I'm going to plug 0 into the f machine. So f of 0 is going to be 0 squared plus 5. And then I'm going to subtract my g machine where there's a 0, which is 4 minus 0. So I end up with 5 minus 4, which is just a 1. All right. Let's do some more examples. This time, the f machine is 5x cubed minus 2x. So take your input, cube it, multiply it by 5, then minus 2, and multiply it by x. This x is an element of R, just means x is an element of real numbers. We can kind of ignore that, just knowing that any real number would be able to go into this function. So let's determine f of negative 3. We're going to say this is going to be equal to 5 times a negative 3 to the third minus 2 times a negative 3. So this is going to be 5 times a negative 27 plus 6. So 5 times a negative 27 is negative 135, plus 6 is going to be negative 129. Okay, let's go over here for letter B. It says find the value of f when x equals 2. So now everywhere we see an x, we're going to put a 2 instead. So this is 5 times 8 minus 4, which is 36. The image of 7 under f really just means f of 7, like this. So everywhere we put an x, we're now going to put a 7 instead. So we're going to say 5 times 7 cubed minus 2 times 7. And 5 times 7 cubed is 1715. Wow, those are huge numbers. Minus 14 is 1701. All right. Letter E, an expression for f of a, no big deal. Everywhere you see an x, you're going to put an a instead. That's all you can do. You're done. Letter F, an expression for f of 2x. All right, everywhere we see an x, we're going to put a 2x instead. So this is going to be 5 times 2x to the third minus 2 times 2x, because I'm replacing every x with a 2x. So this 2 is already there. I replace the x with a 2x. Okay, do the math. And that's your expression. That's all you can do. All right, good. All right, now we're going to get a little more complicated here. Keep in mind that you have a machine. This one is called P, and you're going to put some stuff into that machine. This machine says 4 times the input squared minus 6 times the input plus 1. This time our input is quite complicated. It's x minus 3. So copy down everything that you see in the P machine and do to the input what you're going to do to x minus 3. So here we go. 4. There's an x. I'm going to put x minus 3 instead of the x. Square it. Minus 6 times that input. And add 1. Okay. This is a lot of work. Get ready. Here we go. You need to go ahead and actually work this out. So what is x minus 3 times x minus 3? I'm going to go over here and show you just really quick. It's going to look like this. I'm over here on the side. You can get x squared minus 3x plus 9. So I'm going to put that back over here in my equation where I have the 4. I'm going to put x squared. I'm going to go minus 6x. I'm going to put those two middle terms together, add 9, and carry on. Now at this point, I'm going to take the negative 6 and multiply it inside. Notice it becomes a plus 18. It's a negative 6x plus 18, then plus 1. Okay, more work. Multiply the 4 inside. Copy down the rest of it. I'm going to erase my work over here. Whoops. Okay, now I'm going to combine terms. So I'm going to say 4x squared, he'll stand alone, but my x's will be minus 30 of them. If I take these two with the sign in front, and then I'm going to go 36 and 18 and 1 is going to give me 55, and they're all positive. There, done. That is a simplified expression. And if I recap that, everywhere I saw an x, I put an x minus 3. I squared it, multiplied it by negative 6, and added 1. All right, a few more things to do here quickly. Now, if f of x is equal to 10x minus 3, determine the value of x if f of x is 47. Oh my goodness, we are not replacing x with 47. We're replacing the whole f of x. This whole thing is 47, not the x. That means when I take this expression, I'm going to replace the f of x with 47 and make it equal to 10x minus 3. The actual input is what we don't know. So now if I solve this, I'll add 3 to both sides and get 50. Oops, 10x. So then x is 5 when you divide by 10. So be very careful to do that. Okay, part B is very similar. It says solve the equation. In other words, find x. This means find x if the function itself is equal to negative 23. So I'm going to put the negative 23 where the f of x was, because that's what it says, and do the equation. So now when I add 3, I get negative 20. Divide by 10, and x is equal to negative 2. So that is a very important difference. They're not replacing x. They want you to find the x if the actual function is equal to that. Let's go down here and deal with this question. It's exactly the same as we've done before. But in this situation, as you will notice, they're pointing out they want you to replace the x, the input, with the 4. So that's going to be a quick question. 16 minus 5 is 11. Done. But this question, The f of x is 4, not the x itself. So actually, this one is going to be 4 equals x squared minus 5. So important that you notice how that changes. And now when I add 5 to both, you get 9, and your answer is x squared. Now, one more little situation. You know that if x squared equals 9, x equals 3. But because when we take a square root, we're going to put plus or minus, because a positive 3 squared is 9, but so is a negative 3 squared. All right. One more quick example before I quit, and that is solve the equation f of t equals 75. Again, solving it means find the t. You do not know t. You have the f of t. So you have to replace this f thing with the 75. So you're going to replace this. Oops, I have a mistake. This should be a t. So we add 5, we get 80. We take the square root. Now in this case, because of this little box, it says t has to be greater than 0 only. I'm only going to take the positive square root of it. And we're supposed to answer in simplest radical form. This is going to take you back a bit. You're going to have to break this up into 2 pieces, where one is a perfect square and one is not. And that is going to be 16. 80 divides by 16 5 times. So we're going to put 16 and 5 like that, which becomes 4 root 5. So that's going to take a little bit of remembering to remember that part. Okay, good luck on your assignment. Do all that you can. Look back at the examples if you need help.